Hi guys, this is Vineet, and in today's video we will discuss about heaps, which are tables without clustered indexes inside SQL Server. Before we proceed ahead, I would request you guys to please go ahead and subscribe to the channel. There's a subscribe button below, just below this arrow, somewhere near that arrow below this video. Click on that subscribe button, you will get a bell icon. Click on that bell icon and select all notifications to get notifications regarding all my future videos. Guys, we really need support from your end. Subscribing gives us huge motivation to create new videos for you and for other SQL professionals, so please do subscribe. And right now, if you see the picture on the right, it is showing that out of 100 viewers, only 4% of them are subscribing to our channel and 96% are not subscribing. So far I have around 320 subscribers and around 131 videos posted on my channel. So please do increase the subscriber count, take it somewhere near 500. I would really appreciate, guys. Please take a minute, please subscribe right away. It's easy. And then yeah, let's move on if you have already subscribed. So there are some points to remember. I would request you guys to please watch this video till the end to gain better clarity of the concept, and if possible for you, please watch this video twice to gain better understanding and perform any exercises in your test and lab environment only, and do not touch any production or environment or production databases. And we would like to know your thoughts regarding our videos, so please share your comments with us. In case you need PDF copy of the notes which we are discussing in this video, you can download them so by paying a nominal fee from the link given below. I've also included this link in the description of this video, so please check it out. Check the video description, you will find this link. Otherwise, you can directly type this link over in the web browser. It will take you to the page offering this service, where you can pay a nominal fee to download these PDF notes. And I have some playlist which you can watch. So the first playlist is database design videos playlist, which has around like 30 videos which you can watch. So the link is also mentioned here and also mentioned in the description as well. So better if you can check out the description area, all the links are present in there. Same with business continuity videos playlist. We have around like more than 45 videos in there, so you can check this playlist out as well. And also there's my channel page which you can open by following this link, also included in the video description. And if you have any questions related to SQL Server, you can ask them so by paying a nominal fee of INR 500, and you can make the payment at the below link. The link is also included in the description, so you can check that out. Also, if you need any help in writing your profile while preparing your resume, that service is also available as consultation with an hourly charge of INR 1000, and you may avail this service by going to the link below. Also, this link is included in the description section of this video. Let's come back to the topic, which is heaps, which are tables without clustered indexes. Let's quickly go to my notes and let's discuss this today. So let me select my pen pointer. Let's take blue color today, and let's take the pen mode as pen as pointer. So today we are discussing heaps, which are basically tables without the clustered indexes. We will cover what are clustered indexes in our next video series, so keep a watch, and also subscribe to my channel so that you can get the notification regarding my next video on the clustered indexes. So far on this video we are discussing heaps, which are basically table without the clustered indexes. So let's go through these notes. In case you want to download the notes, link is there in the description. So let's start. A heap is basically a table without a clustered index. We'll talk about clustered indexes later. So heap is basically a table without clustered index. One or more non-clustered indexes can be created on tables stored as a heap. So heap is a table without a clustered index, or heap can be a table without any index as well. But yeah, we can definitely or certainly create some non-clustered indexes on the heaps. And data is stored in the heap without specifying an order. So whenever we insert a row into a heap which is table without a clustered index, so whenever we insert a data into a heap, that data is inserted without a specific order. I mean, row order is not maintained while inserting the data into the table. Usually data is initially stored in the order in which the rows are inserted into the table. So the data order depends upon the how soon in the order of sequence the rows are being inserted in the table. It stays in that sequence, whatever sequence we are using in inserting. But yeah, specific order is not followed. But the database engine can move data around in the heap. So database engine can certainly move some data or rows around in a heap to store the rows efficiently. But those rows are still not in order. But yeah, database engine can try to store them efficiently, but rows are still not in order. So the data header cannot be predicted. So one of the limitations of the heap is that the data order of the rows cannot be predicted in a select statement, like what rows we will get first and what rows we will get last, or if we select top 100 rows, what particular rows will get selected. We are not sure on that. That is the case with heaps, which are table without clustered indexes. And to guarantee an order of rows returned from a heap via select statement, you must use the order by clause. So in order to get data in particular order from a heap, we need to use the order by clause. Otherwise, rows will not come out in order. We will discuss about order by clause later, but yeah, you should have an idea of order by clause if you're going through this video. So I will prepare other videos on the clauses which you can use with the select statement. So stay in tune. Now you need to, for a heap, you need to specify an order by clause to return a rows in specific order. And to specify a permanent logical order, so here we are not talking about the permanent logical order. For storing the rows, we need to create a clustered index on the table. So in order to return a rows from heap, we need in any particular order, we need to use the order by clause. However, if we want to store rows in table in a particular order, so that is what it is saying. To specify a permanent logical order for storing the rows in a table, we should create clustered indexes on that particular table. Otherwise, it is not possible to get rows in order without specifying the order by clause. So these are not heaps. The tables which have clustered indexes on them are not heaps. But yeah, the rows are stored in those tables or clustered tables in the order, so that the table is not a heap. A table which has a clustered index, it's not a heap, to be simple. Now there are sometimes good reasons to leave the table as a heap instead of creating a clustered index. So sometimes there are some good reasons where we keep the table as a heap instead of creating a clustered index on that table. But using heaps efficiently or effectively is an advanced skill, and most tables should have a carefully chosen clustered index. So most of the tables should have a carefully chosen clustered index unless a good reason exists for leaving the table as a heap. So we will talk about that later. So ideally we should create clustered indexes on the table, most of the tables, unless we have any particular good reason that exists for leaving the table as a heap. Now we have a section when to use a heap. So here we are covering some points In what situation we should use a heap instead of a clustered table? Now, when a table is stored as a heap, individual rows are identified by reference to an 8-byte row identifier. So here we are talking about the situation where we are storing table as a heap. How do we refer to individual rows? These rows or individual rows are identified by a row identifier, which is a 8-byte row identifier, and it consists of a file number, the database number, and the slot on that page. So this is the format: file ID, page ID, and the slot ID. And this complete string is a row identifier. The row ID is a small efficient structure. Let's go to the next point. Heaps can be used as staging tables. So this is one application it is saying that heaps can be used in the scenario where we want to use them as a staging tables or the temporary tables, not the final ones, for large unordered insert operations. So if we are performing any large unordered insert operations where the rows are not being inserted in order, we can use heaps. Because data is inserted without enforcing a strict order, the insert operations are usually faster than the equivalent insert into a clustered index or cluster table. So inserting data into heaps are faster if we are doing some bulk operation or if we are doing any unordered inserts. Those operations are usually faster than compared to equivalent insert operation into a clustered index, because in a clustered table rows are inserted in order. They are not inserted without any order. If a heap's data will be read and processed into a final destination, it may be useful to create a narrow non-clustered index. So in case we are using heap as a staging table, there must be some final table where data will get finally inserted from that staging table. So if that is the scenario, if we have to use the data from the staging table and want to insert the data out into some other table, which is a final table or the final destination, we would say, it is useful to create non-clustered indexes on the heaps. Heaps can have non-clustered indexes that covers a search predicate used by the read query. Alright, let's move ahead. Data is retrieved from a heap in order of data pages. So how the data is retrieved from a heap via the select statement? It is retrieved in the order of data pages, but not necessarily the order in which the data was inserted. So the data order is the order of data pages, but not the order of data insert. Sometimes data professionals also use heaps when data is always accessed through non-clustered indexes. So data professionals sometimes use heaps when data is always accessed through non-clustered indexes. So in case we are using non-clustered indexes, we can use heaps, and RID is smaller than the clustered index key. So the situation, if we have a RID which is smaller than the clustered index key, in those situations, and if we are accessing data to non-clustered indexes, in those situations some professionals use heaps. Now if a table is a heap and does not have any non-clustered indexes, so here we are talking about a situation where a heap, which is usually a table without a clustered index, if this table do not have even any non-clustered indexes, then the entire table must be read. So if there are no indexes at all on the table or a heap, then a table scan is required, where entire table must be read. That is known as a table scan, to find any particular row. Even if we need a one row from that table, SQL Server has to do a complete table scan in order to find that particular one row. Now SQL Server cannot seek a read directly on a heap, so it cannot read the widths or row identifier directly on a heap. This can be acceptable when the table is small. So this can be done in a situation where the table is small. If we want to do a complete table scan, that can be done only in the scenario where your tables are smaller. But if your tables are bigger, don't do a table scan. Instead, you should have a either clustered or a non-clustered index defined on that table. Now we will talk about the situations where the heaps are not useful and when not to use the heaps. Do not use a heap when the data is frequently returned in a sorted order. So if you want data to be returned in a sorted order every time, then we would prefer not to use heaps. A clustered index on the sorting column could avoid the sorting operation, because in heaps, if you even if you are using the non-clustered indexes, you will specify the order by clause, right? So that sorting operation is done in the tempdb storage, right? So if we have a clustered index defined on that particular column or the sorting column, that could avoid the sorting operation altogether. So that will fetch results in a faster manner basically. So a cluster index is basically defined on the sorting column. We will talk more about clustered indexes in our upcoming video, so please stay in tune with us. Also, please subscribe to this channel. There's a subscribe button below this video. Click on that button to subscribe to the channel. Let's move ahead. Now, do not use a heap when the data is frequently grouped together. So if we are doing a grouping of data, or if we have a group rows together, we should not be using heaps. Data must be sorted before it is grouped. So this is the generally situation. In order to do a grouping operation, the data is first sorted, and a clustered index on the sorting column would avoid the sorting operation. So clustered index basically avoids the sorting operation that usually takes time. So that will fetch us the rows or result in a faster manner. So if there is a grouping, or if the data is frequently returned in a sorted order, do not use heaps, but instead use a clustered table. Do not use a heap when ranges of data are frequently queried from the table. So if we query a particular range of data from our table, we should not be using heaps. A cluster index on the range column will avoid sorting the entire heap. Alright. Now, do not use a heap when there are no non-clustered indexes and the table is large. So here is another scenario. We should not be using a heap if there are no non-clustered indexes defined on that heap and the table is also large as well, unless you intend to return the entire table content without any specified order. In a heap, all rows of the heap must be read to find any particular row that we have discussed already. So if you want the content of the table as is without any order, in those scenarios only please use heap. Otherwise, do not use heap if it does not have non-clustered indexes and the table is a large table. Another point where we do not want to use heap is if the data is frequently updated on a table, do not use a heap. If you update the record and the update uses more space in the databases, so here why you should not do this? Why you should not use a heap if the table is frequently updated is because whenever you perform the update operation on the record, the update uses more and the particular update uses more space in databases than they are currently using. The record has to be moved to the database that has enough free space. Okay, and this create a forward record pointing to the new location of the data. This creates a forwarded record. So whenever we perform the update operation for a particular record on a heap, and if that update uses more space in the databases than they are currently using, the more space is required for that update operation, and the data page cannot accommodate that where the record is, then that particular record is moved to a new data page that has enough free space, and this basically creates a forward record, which is basically a pointer to a new location of the data, and the forwarding pointer has to be written in the page that held the data previously. So the previous page should store the pointer or the forwarding pointer where the data held previously to indicate the new physical location of the data. This introduces fragmentation in a heap. When scanning a heap, these pointers must be followed, which limit the read-ahead performance issues, which limits the read-ahead performance and causes the performance issues, I/O performance issues, and can incur additional I/O, which reduces scan performance. Alright guys, we are done, and let's go to next topic, which is about managing heaps. How do we manage heaps? And to create a heap, which is a table without a clustered index, create a table without a clustered index. If a table already has clustered index defined on it, it is not a heap. We can drop clustered index from the table to return the table to the heap. That can be done. And to remove a heap, we generally create a clustered index on the heap. It becomes cluster table and do not remain as a heap if the cluster index is created on a table. And to rebuild a heap, to reclaim wasted space, we can do 2 points. So if we want to rebuild a heap, which is basically a table, and if we want any space to be reclaimed, what we can do is we can create a cluster index and that is basically a method to reclaim a space from a heap. First we create a cluster index on that particular heap and then drop that cluster index, and then we can use the alter table rebuild command to rebuild the heap. That releases out any unused or wasted space to the operating system. Now creating and dropping cluster indexes requires rewriting the entire table. So this creation and dropping of clustered indexes requires rewriting the entire table, and if the table has non-clustered indexes on them, all those non-clustered indexes must be recreated. When the cluster index is changed, so give me a second guys. Okay, so alright, so if we are creating and dropping a cluster index, it basically requires the rewriting of entire table, and if the table has any non-cluster index defined on them, those should all be recreated when the cluster index is changed or modified. Therefore, changing from a heap to a cluster index structure or back can take a lot of time and requires disk space for reordering data in SMTP. So this operation is required some space, and time needs a time if the table is larger in SMTP basically. Let's move ahead. Let's talk about heap structure. We will cover this out in our later video. We are not covering it over here. So I think we are fine here. We are done with the content for this video. Heap structure we will cover sometime else in our later videos. So guys, in today's video we have discussed about the heaps, which are tables without the cluster indexes, and we have talked about the situations when it is useful to use a heap and when it is not too useful to use a heap as a table, and discussed about both the situations where we can use heap or we should use heap, and discuss about the situation where we should not use a heap. And apart from that, we have also talked about how you can manage heaps, and we have also discussed one of the scenario how you can reclaim wasted space by creating and dropping the cluster indexes on a table and use the alter table rebuild command. Yeah, but this operation needs lots of time and require disk space for reordering the data in SMTP. So we are done for now. I hope you like this video. If you really like this video, click on the like button, and do post your comments on this video. If you want to share your comments, we would definitely would like to listen to them and would like to see them. And also please share this video with your friends in case you feel this video is useful for them as well. Also please subscribe to my channel because subscribing gives us motivation to create new videos for you and for other SQL professionals. There's a subscribe button below. Click on that subscribe button and it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. So guys, need your support in taking my subscriber count to 500. So please do help us here. Thank you so much for your time on this video today, and you have a wonderful day ahead. Thank you.